Okay, this video is to help you look at the steps that you need to go through to predict what reactions are going to happen during electrolysis. We're going to identify the effects of electrolysis on the electrodes, solutions, and formation of gases. So important chemicals are produced with the electrolysis of water. So water is a really important thing to always take consideration of with electrolysis, and the composition of the cathode, why we don't have to worry about that. Okay, so we'll use this as our practice setup. So notice that we've got, in this particular example, both of the electrodes are made of copper. We've got our battery, so it's electrolysis clearly, and our solution is nickel sulfate. Which end of this is the cathode and which end is the anode? So maybe pause it and make sure you can identify the cathode and the anode. Okay, so this end is the cathode. The electrons come from the battery, the power supply. This is a spontaneous reaction. They're coming from here, going around to here, so reduction is happening here. The cathode is negative, which is the opposite to a spontaneous reaction. Alright, the anode is this side here, because the electrons are being lost from here, and it's undergoing oxidation. So to predict what's going to happen when the electrons move across, you need to look at what chemicals are present. So write down step 1, identify everything that you've got present. So you've got copper solid, nickel ions, sulfate ions, and water. And notice both the electrodes are made of copper. Alright, so if we look on our electrochemical series, you find all of the chemicals that you've got. Step 2, identify which chemicals can be reduced. So here, these are undergoing reduction reactions. So your nickel and your water can be reduced. Which chemicals can be oxidized? These are oxidation reactions, they're losing electrons. So the copper and water. The sulfate and nitrate we don't worry about for electrochemical, these reactions. For year 12 we're not going to look at sulfates or nitrates, so you can ignore them. So step 3, identify the strongest reducing agent of the ones that you've been given, and then we'll look at the strongest oxidizing agents. So the strongest one's going to be reducing first. So the strongest is the lowest. So the copper is the strongest reducing agent, so it's going to oxidize first. And the nickel, the opposite. The higher you go, the stronger the oxidizing agent. So the nickel is the highest, so it's going to reduce first. So you'll notice that these two are closest to each other. They're the choices that are closest. So if we write out this reaction, this is the oxidation reaction. So obviously turn it around to make an oxidation reaction, and the reduction reaction. If we put the two together, then the copper anode is losing the electrons, and they're being given to the nickel in the solution at the other electrode, the cathode, and nickel metal is forming. Alright, so for electrolytic reactions, you notice for non-spontaneous, things that you have to force to happen, you notice that if we drew arrows all the way down till we get to the one that's reacting, and all the way up to the strongest reducing agent and the strongest oxidizing agent, you notice that the arrows don't cross over. So that's one way of noticing that it's an electrolytic reaction, doesn't happen spontaneously. So electrical energy being converted to chemicals. Another way of looking at it is that it's a positive gradient, so positive gradients are not spontaneous. You might have noticed on Edrolo she does a negative gradient, like a slide, chemical here would be sliding down to react with a chemical here. So this is natural, this is not. Alright, so we've got our overall equation, and I talked about this, but we need to kind of refer to the picture. So the electrons are going from the battery into here, they're being removed from this and added to that. So nickel metal. Nickel ions are moving across, positive ions are being attracted across to the negative electrons that are being moved into here. So nickel metal will be being coated all over this electrode. And this electrode, the copper metal, is losing its electrons, becoming copper ions. So the solution this solution will start to go blue. Copper ions in solution make the solution blue, so as you're adding copper ions, it'll start to turn blue, and this electrode will start to get holes in it. If you look on your electrochemical series, I've picked one that's quite complicated actually. If you have a look on your electrochemical series though, copper ions are actually higher up than nickel ions. So copper is a stronger oxidizing agent than nickel. So as these are being produced, the solution will turn blue, but then as they diffuse across here, they will eventually be reduced in preference to the nickel ions, and so you would get an initial layer of nickel being coated on here, and then eventually you would start getting a copper layer on top of that. And the solution wouldn't go any more blue, because as you formed a copper ion, and a copper ion would be reduced, so the solution would stop getting darker. Okay, I have seen questions where they look, even they do your initial reaction and then they start looking at other products that are being formed and how that will affect the original reaction. Alright, so predicting the effects of water. You always, for electrolysis, really need to take account to see if there's water present. So there'll be clues to see if there's water present if it says AQ, aqueous, or if it mentions that there's a solution. So any indication that there's water present, you need to take account of. When considering the potential reactants, you don't need to worry about the cathode, because the cathode is a solid. If it was going to react, it would have to lose its electrons. But if it's the electrons are being forced onto there by the power supply, so any electrons that it might spontaneously lose will be replaced by the power supply. So basically the cathode material is protected and it won't react, so you can ignore whatever the cathode's made out of. So let's look at the effect of water first. What is reaction if inert, so carbon electrons that usually don't react, are put in a solution of magnesium chloride? So first one, what are the chemicals present? So we've got magnesium ions, because this is a salt, magnesium ions, chloride ions, and solution, you've got water. So you need to find those. So you've got chlorine ions, water, and magnesium ions. So the strongest oxidizing agent and reducing agent, in this case, when you look, the highest oxidizing agent, with my little pointer up here, is water, and the strongest reducing agent is water. So water will react with itself. The magnesium and chlorine ions help to balance the charge. They act like an electrolyte. So you need some sort of charged ions in the solution in order for the water molecules to react with themselves. Okay, so if we write out the two half equations, if we write out these two half equations, this is undergoing reduction, so it happens at the cathode. So at the cathode, hydrogen gas is being formed, so you get bubbles of hydrogen gas at the cathode. And at the anode, this is undergoing oxidation, anode oxidation, you get oxygen gas bubbles formed. So both electrodes will be producing gas bubbles. With our hydrogen fuel cells, hydrogen as a fuel for fuel cells to make a whole powering cars as a hydrogen economy, you can electrolyze water. So you can force water molecules to produce hydrogen by electrolysis. So this is an important, we could do this in the lab at school, just by putting a test tube over to collect the hydrogen. It pushes, if you fill a test tube up with the solution, the water, the gas formed will push the water down, and then the entire space up here will be full of whatever gas that you're producing. Alright, so we need to be really careful with the water, particularly if you want to reduce or form any of these metals. Whoops, sorry. So if you are attempting to add electrons to a solution with any of these metals, like that we just did with the magnesium, they will not form the metals if the water is present. So this is a really important thing to note down on your electrochemical series in your data booklet, that the water here, the oxidizing agents right down the very bottom, if it's present, it's the strongest oxidizing agent, and it will react in preference to all of these ions. So you cannot produce these metals if water is present.